Welcome to this session presented to you by Mودمي as part of SAT exam preparation course. Today we are going to talk about linear equations and word problems. First, let's talk about types of related SAT exam questions that you will learn how to solve in this session. The first type is linear equations. You will be asked to find x of a linear equation, direct linear equation you will be given during the exam. Let's say like something like 2x minus 2 equals 0, for example, and they will ask you directly to find x. The other type of the problems is word problems. You will be asked to find a real word value x given other related information. This type requires translating the problem into a linear equation that you have just learned how to solve in the first step. So, what's a linear equation? A linear equation is an equation of the form ax plus b equals 0. Other forms can be presented. Maybe if I have two variables, here I have only one variable. If I have two variables, it can be ax plus by plus c equals 0. In this session, we are going to talk about the linear equations of one variable only. So, how to solve this equation? Typically, we need to focus on a couple of rules that we might need during solving linear equations, whatever is the type of the equation, even nonlinear equations. This applies to nonlinear equations as well. The rules are, if I want to move something from one side to the other side, it changes its sign. So if it's plus, it will become minus. So here ax equals minus b. If I want to get rid of this a, I divide both sides of the equation over a, so I get x equals minus b over a. So why b just changed its sign? Because simply I have subtracted b from both sides of the equation. So ax plus b minus b equals 0 minus b, it's minus b. So plus b with minus b equals 0 and ax equals minus b. That's how we moved this plus b to the other side and became minus b. So all forms of linear equations with one variable are solvable in this way. So whatever is the equation, you might be presented some other forms that need some work to get it to this form. Either ax plus b equals 0 or ax equals minus b or even b. But whatever is the case, you need to reduce it to one of these two forms. Let's have a look on this example. 2x minus 1 equals 3x minus 17 over 3. The first thing you will notice here is that x is multiplied by a fraction that has a denominator of 3. So if you multiply both sides by 3, you will get rid of this 3. At the same time, you can divide both sides over 2 to get rid of this 2. But you still have this 3x, so I think it's better not to rush into dividing over 2. Let's just multiply by 3 and see what we will get first. So when we multiply by 3, we will get rid of this 3. I will get 2x minus 3 equals 9x minus 17. Now, if I move this 9x to the left hand side, it will become minus 9x, and if I move this minus 3 to this side, it will become plus 3. So I can directly write it like this: minus 9x plus 2x equals to 3 minus 17. Now, minus 9x plus 2x equals minus 7x equals minus 14. Now, if I divide both sides over minus 7, I will get the x I'm looking for. Minus 14 over minus 7 equals plus 2. So the correct answer to this equation is 2. Let's have a look on another example. Now, before looking into the next example, how can I make sure that this 2 is correct? Simply by replacing the value 2 into the original equation. You can do this by yourself, of course. 7 over 5x minus 53 over 4 equals 3 over 4x minus 10. I would ask you here to pause this video and try to solve this problem by yourself. And once you finish, or if you want to continue, just continue playing this video. Now, to solve this, again, I will notice that I have 5 and 4 as denominators of the fraction multiplied by x. So I will need to multiply both sides by 5 and by 4. So I will just multiply both sides by 20, which is 5 by 4 equals 20. So I will just multiply both sides by 20. So 7 by 4 is 28 x minus 53 by 5, it's 165. Of course, in the exam you will have the calculator, so there is no problem multiplying such number by any number. This equals to 3 multiplied by 5 is 15. Of course, the 4 has just been reduced due to the multiplication. 15x minus 10 multiplied by 20 is 200. Now I will move this 15x again to the left hand side, and I will move this 165 to the right hand side. 28x minus 15x equals to, sorry, this is 200, not 100, this is 265. I will have 265 minus 200. Now 28x minus 15x is 13x equals to 265 minus 200 is 65, and x here equals 5. Again, how can we make sure that this answer is correct? You can replace x with this value, and you will find that the left hand side equals the right hand side. Now, tips for the final exam or for the SAT exam: you have to be fast and precise at the same time. You can achieve this by practicing. The more you solve before the exam, the faster and more precise you will be. That's it for the linear equations. Let's go for the word problems. What is a word problem? It's a math problem described by words. In general, they can range from simple, very simple, to very extreme and complex problems. But for the SAT exam, they are all reducible to linear equations in general. Some very simple and basic example of a word problem. Let's assume that if Simon is now, or if Simon will be 15 years old after 3 years. So after 3 years, he will be 15 years old. And how old is he now? Actually, this seems pretty obvious, and it can be solved without any effort, but let's just describe it in terms of a linear equation, because we will need this technique in the future. This simple technique, we need it in the future for the more complex problems. Now, we are looking for Simon's current age. So to translate this word problem into a linear equation, I will assume that Simon's current age is X, and after 3 years, so after means plus 3 years, let me just correct this. After 3 years, he will be 15. So this is a linear equation. This is how we translate the word problem into a linear equation. Now solving the linear equation will give me the correct answer, x equals to 12, right away. So let's have a look on our first example. Jack bought a book for $17.5. Now, knowing that the book was sold with a 30% discount, how much is the original price of the book? Now, I'm looking for the original price of the book. Let this price be X. This price, if I reduce 30% of its price, 30%, let me just write it 30 over 100, X, this equals to 17.5. Now again, we reduce the problem into a linear equation, and solving this doesn't make any difference than what we have just solved in the linear equation examples. So let's assume that these are another examples for solving linear equations. X minus 3 over 100, I can just assume that this is 100 over 100, because 100 over 100 is 1. So 100 minus 30 equals 70 x over 100. Of course, you can just say it's 7 over 10x equals to 17.5. Now I will just multiply by 10 and divide by 7, and I will get the answer right away. By 10 it's 175, and over 7, this equals to 25. So the original price of the book is $25. The second example is if Sarah is 9 years less than double Lara's age, and the sum of their ages is 36. How old is Sarah? Here, let me assume that Sarah's age is x, and x equals to double Lara's age minus 9. So let me assume that Lara's age is y, so I will have it x as 2y minus 9. And the sum of their ages is 36. So Lara and Sarah, their ages are 36, the sum of their ages. So I can simply say x plus y equals 36, but I know that x is 2y minus 9, so 2y minus 9 plus y equals 36. So 2y plus y is 3y, and I will just move this 9 to the right hand side of the equation, equals 36 plus 9, it is 45, and y equals 15. So Lara's age is 15, so Sarah's age is 2 by 15 minus 9, so x equals 30 minus 9, and this equals to 21. Let's have a look on the last example we have in this session. An investment account got 5% profit. Given that the profit is added to the original amount and the account now has $1,200, how much is the original amount of the account? Again, this is pretty similar to the first example we solved, with the difference that there we have a discount, but here we have an addition. So let me assume that the original amount of the account is x, and if I have an additional 5% of this x, this would equal to 1,200. So completing this is 100 over 100, just to make the denominators the same. So 100 plus 5 is 105 over 100. X equals to 1,200. This can be written if I multiply by 100 and divide over 105. X equals to 1,200 multiplied by 100. I will just add another 2 zeros over 105. So x, if you use the calculator, x would equal something like 1,142.8571. And there is a very important rule you need to follow in such a case, because sometimes you will have the answer something like this. A, it's 1,142.85. B, 1,142.86. C, 1,142.8. And you may get another option, another choice. You need to make sure that you are rounding to the most accurate number. How can we do this if we face these, for example, 3 options here? First, remember that after the point you can add as many zeros as you need to the right. So this can be read 80, this is 86, this is 85. And which one is closer to the correct answer? Actually, after this 5, I have a 7, and 7 is closer to 6 rather than 5. 857 is closer to 60 rather than 50. So the correct answer, if you are given these 3 options, is B. I just wanted to give you this example to make sure that you might find a situation when you need to make some rounds, and this is an example of rounding. Thank you. Have a good day.